Hello everyone, we are Team 3 and we are doing the hose reel redesign. My name is Noor Hadid and please meet my teammates.
My name is Arushi Salecha.
I'm Johan Asenov.
And I'm Nick Shyland.
The product we chose to redesign is a hose reel. These are simple devices with the primary function of conveniently storing a fluid-carrying hose for easy access at any time. These hoses are intended to be installed in workspaces where fluids frequently need to be delivered to specific locations by means of a hose. When required, the hose can be drawn out of the reel manually by the user to wherever it is needed. After use, the hose can be easily rewinded around the reel thanks to a spindle drive. The hose reel can also be made portable by replacing the wall mount with a portable stand and carrying handle.
This is the exploded view of the hose reel. The reel can be separated into three main parts: the frame, the spring drive system, and the reel. We are treating the spring drive system as a black box as we will not be modifying it.
Our primary customer base are any form of automotive shops. Air tools are the most common form of tools mechanics use when dealing with fasteners to replace components. Another very important air tool is used to check and change tire pressure, which is extremely important for safety. Thus, that makes the hose reel a very convenient choice for them. Our secondary customer base are horticulturalists, which are professional gardeners, and since the majority of elders choose to pick up gardening, having our redesigned, easily maneuverable hose reel will make gardening significantly easier. Estimating our production volume to be over 200,000 parts per year, we can see how that is easily achieved over many university campuses, machine shops, mechanics, oil change shops.
Our main function in our fast diagram would be to store the tube, and this is divided into subfunctions related to housing that tube and other functions that the hose reel should contain, including retracting the tube and protecting the tube.
This is our bill of materials. To estimate material cost, we use the volume and density of each part. To determine material costs specifically, we use the metal chart for stamped and machine parts and the bulk material cost for our ABS and casted parts. To estimate our assembly cost, we assume manual labor, putting it at $90 an hour. To estimate our processing cost, we assumed an annual production rate of 200,000 units per year. Our spring drive system, we assume, is pre-purchased. This total cost led up to be $106.97.
For our assembly sequences, we start from the tube reel, where the assembly can be divided into the reel spindle and the roller holders. After individually completing these assemblies, the roller support and the bridge supports can be separately constructed. The last thing would be adding the wall mount and the hose stopper one at a time. For the wall mount assembly, we can start from the bridge support as well as the roller support, and these include all of the roller components as well. The tube reel then can be assembled in conjunction with other rotating components, leaving just the hose stopper at the end. After looking at the two assembly diagrams, it has been displayed that having multiple sub-assemblies under one assembly, like the roller and spindle components, increases the ease of assembly. This makes the assembly much simpler and therefore shows that the wall mount assembly has a higher ease rating.
This is our function component mapping matrix. As we can see on the chart, there are a few components that are critical to performing many of the functions of the device and therefore represent potential points of failure which must be redesigned. As the components that we have selected as modular and changeable between the two customer categories each fulfill their own respective functions. Our quad chart classification breaks down the parts on the hose reel by manufacturing cost and functional importance. Parts with high functional importance but also high costs are to be considered for redesign. In our case, these are the tube reel, the spring hub, the reel spindle, however, not the spring drive, as we are considering that a black box not to be redesigned. The parts listed as low functional importance are to be eliminated with the next design iteration or brought to a high functional value.
Our product family design can be divided as follows. Most of the components are similar, however, there are different wall mounts for different purposes. Horticulturists would prefer a garden hose, so a mount would be portable, and an auto shop would prefer a mount in an auto shop for an air hose. For these individual hoses, there would be different tube stoppers as well as different wall mounts.
The primary design that we're looking at here is the original CAD design that we started with. Our secondary design has had the wall mount replaced with an easy carry handle and legs that allow the hose to travel freely. Secondly, the tube stopper has gotten larger to accommodate the larger water hose. With respect to the fast diagram, the functions that are not shared across our customer layout are the following: attach to wall, facilitate portability, accommodate tube. We achieve this by changing the wall mount to an to an easy carry handle to facilitate portability and change the tube stopper size to accommodate the tube's girth change. And with that, wraps up our presentation. Thank you so much for listening.